Hey, 8th grade. So our learning target today is I can write and graph equations in standard form. So a new form that we're going to learn again today. We've talked about point slope form. We've talked about slope intercept form. This is our third form in 8th grade math called standard form. They're all very much connected to each other. Standard form is kind of the most unique of the three. So let's talk about what it looks like first of all. So we have what is standard form. We have AX. So a is just a coefficient. So a is a number multiplied by the variable x plus b is a number multiplied by the variable y equals c, which is just a number. So a, b, and c are all numbers. It functions a little bit different than what you've been used to doing with slope. So we'll kind of talk through kind of how this works. So starting off with writing some equivalent fractions. So we have really a 1x and a 1y equals 3. So if we write an equivalent fraction to this, we're asking for another, or I keep saying fraction, I meant to say equation. We're looking for another equation that's equivalent. So a way to think about this is if we were to take the entire thing and multiply it by, let's say, 2. Using the idea of the distributive property, we would multiply by 2 to each of those terms, and you'd end up with the 2x plus a 2y equals a 6. These two equations would become equivalent equations because their values are really equal to each other. Another way to, another example over here, let's talk about some equivalent equations with these. We could maybe say, let's divide each of these by 7. Each term by 7. So we're going to do division by 7. Kind of the same idea of the distributive property where we're multiplying by 7 or divide by 7 because they all have a common factor. So we'd end up with 1x plus, triangle problem here, -3 coming out of that. The variable is y equals triangle problem -7. Those are equivalent equations as well. And then the last problem there, 12x plus 6y equals 3. So if we're asking, well, what is a number that we can take out of 12, that we can take out of 6, and we can take out of 3? We're really looking at something called a factor. What's the factor of each of those? So what number goes into each of those? You could say, well, 3 does. So we'd end up with a 4x equals a 2y equals 1. These two, again, would be equivalent. So the original equation and the new equation are equivalent. We just took a factor of 3 out of each of those, but they really have the same equivalency. So standard form is a little bit different. So really talking about when we have two things kind of varying. Almost feels a little bit like two slopes when you have two things varying. So the example we'll see later in classes, you have this, you're going to put your dog in a kennel. Well, you have to pay for the number of nights that you're staying. Nights is a variable. But you also have to pay for the number of treats you're going to give your dog. So you end up having two variables, which is why we have this form ax plus by equals c. So let's talk through that. So first thing we'll do in our work today is we will find the slope. So we're going to find the slope. And then we're going to write it in what we call point slope form. So you're very comfortable with that because we just spent 2 days doing that point slope form. So we have the point, we have the slope, and then we're going to rewrite to y equals mx plus b. So steps 1, 2, and 3 you've been doing for the last 3 days in class. Old news. What's brand new is step 4. This is new. We're going to rewrite then in what's called standard form. And then, of course, our last step is just to check to make sure everything seems legit. Okay, so go ahead and get those notes down, guys. Okay, so what we're going to do now is we're going to talk about writing an equation in standard form. So the first thing that we need to do is we need to find the slope like we've been doing forever. So here's my hotel room. There's my best friend's hotel room. We talked about finding the slope up and down on top, left and right on bottom. So to get from my room to friend's room, we're going to go down 2, and we're going to run over 2. So the slope is -1. Slope is -1. And now we need to pick a point. You can pick either point as we've learned. So I'm going to go ahead and just pick one of the data points. I'm going to choose this one, -1, 3. Okay, so that's first step is to get the slope, and we need to grab just one of the points. Okay, step 2 then is we're going to rewrite the equation in point slope form. Since we have a point and a slope, we use point slope form. So we're going to say y minus 3 is equal to the slope. And then we have x minus, careful, watch the sign there, -1. Okay, so that's point slope form. What we're going to do is we're going to rewrite that into y equals mx plus b for step 3. So I have a hand method going to happen here. I have a lonely variable, and I said no there. We go ahead and use that distributive property. We distribute, give us -1. Reattach the variable, which is x. Distribute again is a -1. On the left-hand side, we have y plus -3 equals. So we've killed that parenthesis. Hand method kicks in. We're going to add 3, copy, paste. So we have y equals -1x plus 2. Y equals -1x plus 2. So that is what's called y. That's our slope-intercept form. What's brand new for our work today is step 4. We're going to take this form and we're going to have to write it into something called ax plus by equals c. So we basically solve for c, the constant this time. So we're solving for c. We've never done this before. We always solve for variables. So to solve for c, hand method, what we would want to do is we would want to get rid of the -1x, solving for this. So we're going to add 1. Sorry, I don't know what happened there. Add 1x, copy, paste. But we're going to paste it off to the side. I'm going to go ahead and rewrite this, guys, because I'm having trouble with my pen. So I'm going to start down here and start over. So we have y plus -1x equals 2. We want to solve that for c, hand method. So the goal is to lock this in. Whoops. I need to start over again. Sorry about that. I don't know what's going on with this pen. Sorry about this. We have y equals -1x plus 2 was what the equation that we had right here. Solving it for c now. Hand method kicks in, so we're going to lock this 2 here. To get rid of this -1x, we're going to add 1x, copy, paste. Now, when we paste it, we need to paste it off to the side because these are unlike terms. If I haven't used it, drag it down. So we have 1x plus y equals 2. This is our ax plus our by, which is really like a 1 there, equals our c. We nailed it. There's our equation. And step 5 is to check. And now in this video right now, I am not going to run through the check because I don't want to confuse you. But we would go ahead and want to check that after we're done. So that's called standard form. We'll talk about why we use that as we proceed through this lesson. But that's the form that we're going to work on today. All right, so we're going to try another problem of standard form. So the first thing I need to do is get the slope here. So we have our x1, y1. We have our x2, y2. So our equation is y2 minus y1 over x2 minus x1. Finding slope. We've been doing this forever. Okay, let's keep on rolling here. So we then have y2 value is -3. The y1 value is -1. The x2 value is 2. And the x1 value is 3. I said no. I stopped chop chop, which is -2. I said no. I stopped chop chop, which is -1. So my slope then on that is +2. All right, so now that I have the slope, I need a point and I need a slope. So I just go back up and I grab one of the data points. I'll grab this first one. And I write it in point slope form because all you need is a point and a slope to do that. So we'd say y minus y1, watch your signs there, is equal to the slope. And then we have x minus x1. That's called point slope form. As I start to solve, I'm going to solve this for y for step 3. So we're going to go ahead and say, I said no, we chopped that. What is going on with this pen? I'm going to start over and erase all of this. Sorry about that, guys. So we have y minus y1 is equal to the slope, x minus 3. Okay, so I'm going to chop this. We have a lonely variable, and I'm going to chop that. Using the distributive property, we're going to distribute. Kill that parentheses, 2x plus, distribute again is -6. On the left-hand side, we have y plus 1. Hand method kicks in. We subtract 1, copy, paste. So we end up with y equals 2x plus -7. Now our job for today is to turn it into what's called standard form. Ax plus by equals, this is supposed to be a -7. My pen is really having problems today. Sorry, I'm writing on this tablet and the pen is struggling. I'm going to solve that for c. Ax plus by equals c is what I need. Ax plus by equals c. Solving for the c, the constant this time. Hand method. Put my hand on that. That's a giant stop sign. Anything by my hand has got to go. You have to, for the very first time, or the second time, I should say, because we just did in the last problem, subtract 2x. Solving for the constant. Copy, paste. Now when we paste it, we want to paste it off to the side because these are unlike terms on the left-hand side. If I haven't used it, drag it down, and I end up with a negative 7 on the right. So my equation then is negative 2x plus y equals negative 7. That's called ax plus by equals c. We're not going to worry about checking it because I don't want to overteach it and confuse you in this video. But that would be our answer for standard form. So let's talk about now when we would actually use this in real life. So our first example for real life is a situation when you have really kind of a double variable, some variation going on. So you have this dog kennel that charges $20 per night. So that's going to be a variable. And then $5 per doggy treat. So there's two variations happening. So we're going to say that we're going to write an equation that models the combinations of nights and treats you could buy for $100. So I have $100 to spend. What are some of the possible combinations that would work? So if we say X is the number of nights that the dog is going to stay, which could vary, that's why it's a variable, and Y is the number of treats, which we have a true variable equation, what could happen? We know the constant in this problem, it's $100. We didn't lock that in. So that's something that's a known two variable problem. So our equation would be then, it's going to be $20 for each night, and it's going to be $5 for each treat. So this is our standard form equation. So how does that work then? Well, really our data points would be pretty simple. So we'd have, what happens if I want to say 0 nights? Well, if I'm going to say 0 nights, it's sort of confusing because then would the dog get any treats at all? Well, if I stay 0 nights, I guess I could just, and I have $100 to spend at this dog place, I can buy all the treats, all $100 worth of treats. So I plug in 0 here, and that means that I could buy $20 worth of treats. Kind of a weird problem, but that's still, if you have $100 to spend, that's what you can do. Or I can spend, say, 1 night. And if I stay 1 night, that's my $20 is gone. That leaves me $80 to spend on treats, which would be a problem of how many dollars can I spend on treats. So we're saying that, so here's my 20 for 1 night. And I'm really saying, well, how much can I spend on treats? So I think I could spend 16. I could get 16 treats for $80. All right, so what if I want to stay 2 nights? My dog can stay 2 nights. So 2 nights would be a situation, well, that's $40 for sleeping. So here's my equation. And that leaves me with $60 to spend on treats. Well, if I have $60 to spend on treats and they're $5 a piece, that gives me 12 treats that I can buy for my dog. So my dog can stay for 2 nights and get 12 treats for the duration of the time the dog stays. Or my dog can stay for 3 nights. Well, what happens if my dog stays for 3 nights? Well, I'd have to pay $20 for 3 nights. And then that means that $60 is gone for sleeping. That leaves me $40 for treats. So $40 and they're $5 a piece. I can buy 8 treats for my dog. All right, what if my dog stays for 4 nights? So maybe you can kind of see a pattern that's happening here for 4 nights. $20 for 4 nights. That's $80 gone for nights. That leaves me $20 for treats. They're $5 a piece. My dog can get 4 treats then. If my dog stays for 4 nights, the dog would get 4 treats, so 1 treat every night. What if my dog stays for 5 nights? I only have $100 to spend. So we would say, well, what happens then? That's $20 for 5 nights. How many treats does my dog get if I have $100 to spend? Well, the problem is all $100 are gone for sleeping. That means my dog would get 0 treats. So to graph this, we would say, dog hotel. Let's say something like that. All right. So the Y is the amount of not amount of money, actually. Whoops, I kind of messed that up. Sorry about that. Is the number of treats the dog gets. X is the number of nights the dog's going to stay. So these are my treats. And these are my nights. So we have kind of a lot of space to use here. And I think maybe I'll just go by ones here on the nights. So my dog can only stay 5 nights. I only have $100 to spend and it's $20 a night. So that's the most my dog can stay. But in terms of my treats go, my dog can stay kind of a variation of treats. So we would say my dog can get 4 treats, 8 treats, 12 treats, 16 treats, 20 treats. So let's go ahead and graph that out. If my dog does not stay at all and I just stop by the place, my dog will get 20 treats. If my dog stays one night, then my dog can get 16 treats. So we can spend the rest of the money on treats because I have $100 to spend. If my dog stays 2 nights, then I can get $12 or 12 treats. They're $5 a piece. If my dog stays 3 nights, that's $60. There's $40 left to spend on treats. They're $5 a piece, so my dog can get 8 treats. If my dog stays 4 nights, that's $80. That means $20 left to spend on treats. They're $5 a piece. My dog will get 4 treats. So 4 nights, my dog gets a treat every night. If my dog stays 5 nights, the bad news is my dog's not going to have money to get any treats. So there's the graph of the equation. So this is what's called standard form. It's the first time you've seen it. It's when you have really 2 variables going on in the problem. There's some variation. So for your summary today, I would like you to go ahead and write down all of these things that you see, kind of the 5 steps that we talked about. And then your homework for tonight will be to finish page 40, do 41, and do 42 due tomorrow. 40, 41, 42. Have a fabulous night, 8th grade.